Hello students, how are you? Okay, so today I am here to discuss the JEE Advanced paper 2. So the first section is having three single choice correct questions, which is having 4 questions, then multiple choice, then numerical types. Okay, so let's start with the first question only. It says a metal wire of cross section 0.5 millimeter square and length 100 meter is connected across a battery of EMF 2 volts and internal resistance 1 ohm. The density, atomic mass and the electrical conductivity is given, and we have to find out the drift velocity. So here, if you look into this, they have given you some information about the EMF of the circuit and its internal resistance, which is having some internal resistance R, and the external resistance, that is capital R. Now, as you can see that the EMF is given to you as 2 volts, the internal resistance is given to you as 1 ohm, and for the external resistance, we can use the formula rho L by A, but since the resistivity is not given, the electrical conductivity is given, so you can use L by sigma A. Now substituting these values, L is 100 meter, sigma will be, the electrical conductivity will be 6.35, not 6.35, electrical conductivity is 2 into 10 to the power 8, and area that is given to you 5 into 10 raised to the power minus 7. So by solving this, we are getting 1 ohm, right? So external and internal resistance both are equal in magnitude, and that's why the current in the circuit that will becomes E upon R plus R, as it is a simple resistance circuit. So this is giving you 2 upon 1 plus 1, that will be equals to 1 ampere. This way you are getting the amount of current which is flowing in this circuit. Now this current will help you to find out the drift velocity of these electrons, right? So as you know that in the mechanism of the current, that this I can be related with the drift velocity as NEAVD. That means this VD will be equals to I upon NEA. Current you already know. E is the charge on the electron. Area is also given to you 5 into 10 to the power minus 7. So the main focus is on this N. Now what is this N? N is the number of free electrons per unit volume of the conductor. N is nothing but what? Number of free electrons in the per unit volume of the sample. So here N is what? It is the free electrons per unit volume. As given in the question, it is given to you that there is one free electron per atom. That means I can say it is one free electron per volume of one atom, right? And to find out the volume of one atom, we can use the molar mass, means it is the mass of 1 mole. So one atom will be m by Na, that is the mass of one atom divided by density. All right, these values we can put, which is given to you. So for metal wire, 63.5 grams per mole, that will be the molar mass. So 63.5 into 10 raised to the power minus 3 kg per mole. Then this Avogadro number, that will be 6 into 10 to the power 23, 6 into 10 to the power 23, and then you have the density as 6.35 into 10 to the power 3. 6.35 into 10 to the power 3. All right. So this way, when we solve this, we can say this is 10, this is minus 2, this will plus 5, this is, so 1 upon 6 into 10 to the power 28. That will be the volume of one atom, which means the value of small n, which is one free electron per unit volume, that will be 1 upon 6 into 10 to the power 28, means the n value will be 6 into 10 to the power minus 28. All right. Now substitute in the previous expression to find out this Vd. So what is this Vd? It is I by NEA. I, as we have calculated as 1, this is 6 into 10 to the power minus 28. Is it? No, this is also plus 28, right? So this is plus 28. E value will be 1.6 into 10 to the power minus 19, and the area is 5 into 10 to the power minus 7. It is 0.5 millimeter square, means 5 into 10 to the power minus 7. So we can easily solve this thing. This is 1 upon 30. 30 into 1.6 is 48 into how many powers are there? This is 26. This is 28, 26, 28. So this is 10 to the power minus 2. All right. Now, as given, you have to find out this in millimeter per second. This is meter per second. So for millimeter per second, we have to multiply with 1000. So that's why if I multiply this with 1000, then what will happen? It is 1000 divided by 48 multiplied by 100. All right. So this will give you 10 upon 48. Now we can solve it. It is coming 0.208. So option C is the right answer for this 0.208. That will be the right answer, option C. All right. Quite a familiar question. The same to same question will be given in SC Verma also and in our package also, right? So first question was the easiest one. Okay. Move to the next one. It belongs to modern physics and the radioactivity. They are talking about the nuclear reactor starts producing the radioactive nuclide X from T equals to 0 at a constant rate alpha per second. Each decay of X produces energy E naught, which utilized to heat the liquid of mass M. Okay. So what is happening? There will be a formation of X with a constant rate of alpha, and then after it is decaying with a decay constant lambda, right? So suppose at some instant, at some time t, if I am assuming that there are n number of nuclides of X, that means what will be the decay rate? What will be the decay rate of X? That will be minus dn by dt. That is the decay rate. That will be equals to lambda n. All right, lambda n, as we know. But formation is also there. So if I say what is the total rate of formation? Rate of formation of X, then you can say it is dn by dt, that is equals to alpha minus lambda n. All right, alpha minus lambda n. Now we can solve this. So it is dn upon alpha minus lambda n, that is equals to dt. Integrate from both the side, put the limit from 0 to n in 0 to t time. And solving this, what is n you are getting? You are getting n is equals to alpha by lambda into 1 minus e to the power minus lambda t. Simple integration. Okay, you can follow, and this is the value of n. So here they are talking about each decay of X produces energy. Each decay of X. That means what else is given to you? That energy which is being decayed during the decay will be E naught. Means per unit nuclide, E naught is the energy which is being released. Right? That means I can say this dE by dt, that will be equals to E naught into dN by dt. And this dN by dt is nothing but, this dN by dt will be lambda n. And this lambda n is nothing but, it is, as we have calculated before, this lambda n is nothing but alpha 1 minus e to the power minus lambda t. Alright. Now this energy which is being released is used to heat up the liquid. Heat up the liquid of of mass m with the specific heat capacity. So it is utilized to heat the liquid. That means this energy rate will be using to increase the temperature per unit time, ms delta T by dt. That means this is giving you the rate by which the temperature of the liquid will be increasing as E naught into alpha divided by ms 1 minus e to the power minus lambda T. All right, and which is, I suppose, will be in the option as lambda E naught 1 minus, so it is the option C. No, it is the option A, alpha E naught. Okay, alpha E naught. So it's not option C, it is option A. Okay, alpha E naught by ms 1 minus e to the power minus lambda T. I hope it is clear to everybody. Okay. So again, a moderate question. Next questions belongs to prism optics, and they are using the Catch's equations also, in which the refractive index will be depending on the wavelength. So refractive index will be depending on wavelength as alpha lambda plus beta by lambda square. That will be the refractive index in terms of the wavelength. Also alpha beta values are given and they are in micrometers, so I am going to use the same unit. Okay. Here they are talking about minimum deviation. So if I say what is a deviation, then deviation will be n minus 1 into A, which means this deviation will be alpha into lambda plus beta by lambda square minus 1 into A by substituting the value of n. Here they are talking about the lambda minimum is the wavelength at which the angle of minimum deviation is. So minimum deviation is smallest. So this is the minimum deviation formula which I have to make it smallest. Means I have to search for the minima. At what lambda this minima will happen. That means it is dm divided by d lambda, because lambda is variable here. So if I do that, what it will give me? It is giving me alpha minus 2 beta by lambda cube into A. Third term will be 0 because it is a constant, and that I have to make it 0. Is it? That I have to make it 0. So by this way, we are getting this lambda, which they are calling as lambda minimum, as 2 beta by alpha whole cube. Alright, now substitute these values. So it is whole cube of 2 into beta. Now what is beta here? Beta here is 0.096 micrometer square. Micrometer square divided by, okay, this is alpha. This is alpha, right? As you take this term here, it will be 2 beta by alpha. So alpha value will be how much? Alpha value will be 3 micrometer inverse. So it will come cube. Right? This way we are getting 0.000. This is 3, this is 2. So we are getting 64 by 1000 under root of cube root of 64 by 1000 whole cube micrometer. Alright, and this lambda minimum value will be coming as, so cube root of 64 is 4 by 10, 4 by 10 means 0.4. 0.4 micrometer is the minimum wavelength or lambda minimum for which the deviation is smallest. Now we have to find out the value of that smallest deviation. So this is the expression of minimum deviation, which is alpha lambda by beta by lambda square minus 1 into A. So now you already know this value of lambda minimum. Put this value and get the answer. So this is 3, this is 0.4 plus this is 0.096 divided by 0.16. 0.4 square is 16 minus 1 into A. And A is given to you how much? A is given to you as 6 degree. So this becomes 1.2, this becomes 0.6, this is minus 1 into 6. This is coming 0.8 into 6, which is coming 4.8 degree. So the answer goes as 4.8 degree, which will be the option 2. All right. This calculation is right. 0.8 into 6, right. So it is 4.8. 4.8 degree. All right. 4.8 degree. Yes, 4.8 degree. So let's move to the last single choice question of this paper. Then I think there are 2 or 3. Yes. So single choice are 4 questions only. So this is the 4th one. What it says: a particle of mass m and angular momentum L is moving in a circular orbit of radius r under the influence of an attractive force minus k by r square r cap, keeping its angular momentum unchanged. So one thing which you have to notice here is L is constant. L is constant, which in the circle, if it is moving, you can write down as mr omega square. All right. Okay. The particle is displaced radially. So particle is displacing radially. That means this r is variable here. Okay. R is variable here, so omega will also be there. So now what we can write down, if you see the net force, net radial force, then one is the central force, which is k by r square, radial inverse, and one in the frame of this particle will be mr omega square, which will be your centrifugal force. Here for the angular momentum, it is I omega. So I omega you can write down as mr square into omega. All right. All right. Okay. So this is the thing which you are getting. Force is this. Now the particle is moving in a circle. Try to understand this. Here there will be one force which is radial inverse, and in the frame of this there will be, since you are radially displacing it, so the simple harmonic motion or periodic motion will take place along the radial. That's why I need to sit in the frame of mean position. So that's why I am applying the centrifugal force as mr omega square. And now we are keeping this omega in terms of r. So if I put it here, omega in terms of r, I can write down omega as L by mr square. L by mr square. All right. L by mr square. Now substitute here. So it is giving you minus k by r square plus m into r into L by mr square whole square. All right. This is the force. Since for any oscillation, first we need to find out the mean position. For mean position, what you can do? Mean position is the position where the force is 0. So you can say where the force is equals to 0. For force is equals to 0, you will get the value of r naught. That will be minus k by r square. That is equals to mr omega square. If I put it 0, it becomes plus this r is equals to k by m omega square. All right. Or otherwise, you do one thing. I want everything in terms of angular momentum, so I will not put in terms of omega. Rather, I will make this term to be 0. Which term to be 0? Which is in terms of r only. So make it this term to be 0. Okay, for the mean position. So what you are getting here? K by r square, that is equals to m L square by m square r to the power q. Is it? Yes. This r cancel. So from here you are this m on m also cancel. This is your position or radius at the mean position, which will be L square divided by mk. Okay, this is the position. At mean position, what is the radius? Radius will be L square by mk. Now for the time period of oscillation, as you know that this time period will be equals to 2 pi under root of m by k. All right. And what is this k? This k you can write down as, you know that for the linear system it is minus kr, or you can say df by dr, or minus df by dr will be equals to k. Okay, so I can also write down this thing as m divided by minus df by dr, or you can say magnitude of df by dr. This way you can find out its oscillation. So now let's do that. So force expression you already know. What is the force expression here? The force expression here is, in terms of R, is minus k by r square, and then it is L square by mRq. L square by mRq. All right? Yes. So what is df by dr? What is df by dr? df by dr will be equals to minus 2, that make it is plus s upon r cube, plus, no plus, it is minus 3 L square by m r to the power 4. Okay? df by dr. This will be at r naught, at r equals to r naught. And what is this value of r naught? We calculated before at the mean position. What is this value? So this value comes as L square by mk. So this is L square by mk. So I am just going to substitute this value. So what is df by dr? df by dr will be 2k by L to the power 6 mq kq minus 3 L square by m L to the power 6 m to the power 4 k to the power 4. All right. So now we can solve it. It is coming minus df by dr. 3 minus 2 is 1. Minus 1 minus 1 minus will make it plus. Here it comes as, this is L to the power 8. So 2 and 8 becomes 6. This is L to the power 6. Here what is remaining? Remaining thing is m cube and k to the power 4. Alright, now substitute this value for the time period. So it is 2 pi under root of m by df by dr. What is the df by dr value? That is k to the power 4, L to the power 6. Alright, solving this, we are getting 2 pi L cube divided by m square. So 1 m will come out, and this k to the power 4 will give you k square. That will be your final answer. So 2 pi L cube by mk square. 2 pi L cube by mk square. That will be your option 1. Alright. By displacing radially outward, it will start doing periodic motion along the radius. So obviously it is moving, but in this moving frame, if we are taking both the frames, to make it stationary, I will be just going in the frame of this particle and applying pseudo force, which is centrifugal force. And then after, you can check what is the net force along the radial direction, put it 0, get the value of r at the mean position, then df by dr. Substituting this value, we are getting the time period. What is the time period? Time period will be 2 pi L cube upon mk square. So this is about just single choice questions. All the four questions will be there, which is single choice. Now we'll move to the multiple choice. Okay, multiple choice questions. They are a bit lengthy, right? They are a bit lengthy, and since it is multiple choice questions, so sometimes it is hit and trial also. Like you have to check each and every options carefully, right? Okay, so the first question, let's move to the first question, belongs to the deviation prism question, optics again. So here, first let's note about some points which will be like by the diagram, we can find it out. So here, if you see, these phases are vertical. These phases are vertical. These phases are vertical. That means if this angle will be A1 by 2, this angle will be A2 by 2, then A1 by 2 plus A2 by 2. That will be your angle theta. As you can see in the diagram, this angle plus this angle, the sum of the angle will be equals to theta. Okay. So the first relation which you are getting, theta equals to A1 plus A2 by 2. All right. What is the other information we can get here? See, since these faces are vertical, so these two faces, these normals are horizontal. and here the reflection is taking place at this plane mirror. That means these angles are equal. So obviously, for all the conditions, this E1 is equals to I2. So these two conditions are always true. Always true. That E1 is equals to I2 and A1 plus A2 by 2 is equals to theta. Now let's check the conditions, other conditions. And other conditions, and you can see that, like, I already talked about this. Phase A1, B1, A2, B2 are perpendicular to the mirror, means they are vertical, and as the mirror is horizontal. Okay, now come to, and A1, A2 are the prism angles. Okay, if both the prism are at minimum deviation condition, then N1 by N2. Okay, now what is a minimum condition? Minimum deviation condition for a prism. So you should know this thing, that in case of minimum, your I will be equals to E. That is first thing, I will be equals to E. The second thing is what? That R1 equals to R2 is equals to A2 by 2. A by 2, right? Half of the angle of prism. And in that case, if I am talking about minimum deviation, then you can find out this minimum deviation as I plus E minus R1 plus R2, which is A, or you can say 2I minus A, that is your minimum deviation. Okay, so this is, you already know. With the refractive index, you can relate it as sin I by sin R, sin I by sin R, and R you can write down as A by 2 for the minimum deviation. So this much we know, that whenever the deviation is minimum, these conditions will be fulfilled. Here in this diagram, if you see, they are in the first option, they are saying both are at minimum deviation. What does it mean? Both are at minimum deviation. That means clearly I1 is equals to E1. That is the minimum deviation for first prism, and I2 is equals to E2. That is the condition of minimum deviation for 2, as well as if I1 and E1, if these are angles are equal, that means A1 and A2, they are also equal, which is equals to theta by 2, or theta, not theta by 2, theta. All right. So this much we know. This much we know for these two conditions. Okay. We are going to write down the condition for first one, right? Refractive index of 1, that will be equals to sin I1 by sin R1, and sin R1 is nothing but A1 by 2. Similarly, what is N2? N2 is sin I2 divided by sin R2. What is R2? That is A2 by 2. Since both are at minimum deviation, that means clearly I1 and I2 are equal. So if I divide these two, N1 by N2, what I am going to get? I am going to get sine of A1 by 2 and sine of A2 by 2. Okay, because I1 equals to I2 for the minimum deviations, clearly what we can say these two terms will be cancelled out, and this is how you are getting. So is it the right option? Yes. N1 by N2 is equals to sine of A2 by 2 upon sine of A1 by 2. Here it will be reverse. Reverse means N2 by N1. So yes, it is correct only. So first option is correct only. First option is absolutely correct only. Next, if the prism 2 is having the minimum deviation condition, then, so if only 2 is having the minimum deviation condition, that means only minimum deviation at 2, then we can only say that sine of I2, that is equals to N2 into sine of A2 by 2. So here, if you see the second one, prism 2 is at minimum deviation. That means your RHS will be matching N2 sine of A2 by 2. Now what is on the LHS side? It is sine I1. But here it should be sine I2. You have to think whether sine I2 will be equals to sine I1. Yes, it could be possible if both are at minimum deviation, because that is the condition which we are getting by the first thing, that I1 is equals to I2, right? I1 is equals to I2. But here, this I2 cannot be replaced by I1. But why? Because the minimum deviation is only in 2. not in 1. That's why this condition will be true, but the condition which is given is not true for the minimum deviation only in prism 2, right? So that is why the option B will be the incorrect one. C option, what they are talking about? The angle, the minimum deviation. So theta they are talking about. So as I told you that the minimum deviation you can write down in this way. That means from here, if you see what you can write down this I as, you can write down as delta M. Okay, so here theta. So as I told you, theta is what? Theta is A1 by 2 plus A2 by 2. A minimum deviation is n minus 1 into 8. Alright, that means this A1 you can write down as, or A1 by 2 you can write down as delta M1 upon N1 minus 1, and this 2 is as it is. Similarly A2, so if I substitute this value here, what is the theta value I am getting? It is delta M1 by 2 N1 minus 1 plus, what is A2 by 2? That is delta M2 by 2 N2 minus 1. Alright, so option 3 is also right. Okay, they just wrote it A1 by 2 and A2 by 2 in terms of deviation and the refractive index. So third option is also right. Now fourth option, if prism 1 is in the minimum deviation condition, okay. So if prism 1 only minimum deviation is in 1, means what? Sine of I1 is equals to N1 sine of A1 by 2. Since it is a minimum deviation, that means this is also equals to sine of E1, that is equals to N1 sine of A1 by 2, because you know that for minimum condition I1 is equals to E1. And as you can see, I wrote it the first condition that E1 is always equals to I2 because of this reflection thing. That's why no matter whether this is the condition fulfilling the minimum deviation or not, this is always true. So I can replace my E1 by I2. That means this sine I2, that will be equals to what? That is equals to N1 sine of A1 by 2. That means if only minimum deviation in 1, then also this condition is always true. So D option is always true. That means the answer of this question will be A, then C and D. A, C and D. Alright. So little lengthy, obviously, because there are more than one choice. That's why you need to look after of each and every options carefully. Okay, move to the next one. Right. In a vacuum chamber, a particle of mass 1 milligram and charge 1 microcoulomb is projected with a velocity of I plus 2 j cap. Find in the exact plane at time t equals to 0, an electric field will be 1 I cap volts per meter. At t equals to 0.2, the electric field is switched off and the magnetic field. So it's a combination of the Lorentz force, combination of both. But remember, Lorentz force is fine, but electric field is one time and magnetic field is at the other time. So in the region t less than 0.2, electric field is only acting. After t greater than 0.2, only magnetic field is acting. So that's why we have to deal like that. First, here the coordinate system. So first j cap is vertical. So since gravity is j cap, that means this is the direction y. Because gravity will be here and this will be equals to minus 10 j cap. That means I will say this is my ay, acceleration in y direction. Acceleration in y direction. All right. So ay will be equals to minus 10. I write down here. Ay is what? Minus 10 meter per second square. Okay, then field, electric field is in the I direction. So this is the x-axis. So electric field is in the I direction, which is 1 I cap. That means the initial force in x direction it is experiencing as QE, and initial acceleration it is experiencing in the x direction is QE by m, as E is in the x direction only. So when we put this value, it is 10 to the power minus 6 coulombs, and mass is milli and gram. So milli and gram in kg will be 10 to the power minus 6 again. Into electric field is 1. That means this is coming 1 meter per second square. So now you got AX and AY. In X direction there is an acceleration of 1 and in Y direction there is an acceleration of minus 10. Now this particle will be projected with a velocity of I plus 2 j cap. This is the initial velocity under these accelerations. So let us say where it will be at 0.2. So at t equals to 0.2 seconds. At t equals to 0.2 second, let me find out the velocity as well as coordinate. What is Vx? Vx is ux plus axt. So that will be equals to your ux is 1 and ax is 1 and t is 0.2. That means it is 1.2 meter per second. That is the x component of velocity. What about Vy? Vy will be equals to uy minus ay into t, because acceleration, or plus ay into t, later we put the sign. So uy will be 2, ay will be 10 and time is 0.2. That means it is coming 0. So at t equals to 0.2, the velocity will be completely in x direction. That means this is the instant t equals to 0.2 seconds. When velocity will be only in x direction, and that is equals to 1.2 meter per second. Alright. Now the electric field is switched off, so there will be no x. But magnetic field will be there, which is now in the vertical direction. B is equals to 6j cap. Now this is interesting. Gravity is downward, magnetic field is up. But please don't think that because of this magnetic field, force is also in this direction. No. If you see V cross B, force is coming along z direction. So force is along z direction, that means there will be a helical path like this. Velocity is here, force is here. Velocity is here, force is here. So it goes like this. It goes like this. So there will be a helical path. It goes like this. But since there is an acceleration in the y direction because of gravity, so now this is having the helical path with increasing pitch. Yes or no? So what is that? That is a helical path or helix with increasing pitch, because in the direction of the pitch there will be acceleration with increasing pitch. Increasing pitch. Who will decide the radius of this helical path? So radius of this helical path will be mv by qb. mv by qb, which we can calculate as 10 to the power minus 6 kg upon 10 to the power minus 6 microcoulombs. Velocity will be 1.2 and this V is 6. Alright. That means from here you are getting 0.2 meter. 0.2 meter, which is 20 centimeter. So this is a helical path with the radius 20 centimeters. So clearly option C, we got it. What is that? The radius of helical path is this. Okay, at 0.2. After that means it is moving in the helical path with 20 centimeter. Some more information also they are asking at different times. At t equals to 0.3, they are asking what is the y coordinate. They are asking what is a y coordinate, and they are also basically y coordinate only. So let's talk about at these 3 instants. So first is at t equals to 0.3. Up t equals to 0.3 second. After 0.2, after t equals to 0.2 to 0.3, only acceleration will be acting. So there will be no velocity in the y direction, only acceleration is there. That means how much is the y coordinate will change in that 0.1 second? So you will say half into ay, that is 10, into 0.3 minus 0.2, that is 0.1 whole square. So if we solve, we are getting 5 centimeter. That means this changes 5 centimeter. So in the vertical direction, it will move 5 centimeter. Whereas if I check x and y coordinate at 0.2, okay, here, this is little lengthy. At t equals to 0.2, if you are checking what is your x coordinate and what is your y coordinate, you can do it by uxt plus half axt square, which will come as 0.22, I think so. And when you check this UYT plus half AYT square, this will come as 2 into 0.2 minus half into 10 into 0.04. This is 0.4 minus 0.2 gives you 0.2 meter, which is 20 centimeter. So at t equals to 0.2, this distance y will be 20 centimeter, out of which in next 0.1 second it is moving 5 centimeter below. That means what is your final y coordinate? That is 20 minus 5. That means it is 15 centimeter. So here you can see that the vertical distance from the xz plane at t equals to 0.5 is 15 centimeter. Yes, obviously right. Okay, so first option is right. Now we have to also check at 0.4. So let's check on 0.4 also. So when I'm talking about at t equals to 0.4 means which interval we have to take? We have to take the interval 0.2 to 0.4, in which what is the amount of y coordinate will be changing? It is half into ay into t square. That t square will be 0.4 minus 0.2. So that means it is half into 10 into 0.4 minus 0.2, that is 0.2 whole square. And this thing will be coming as 20 centimeter only. So change this 20 centimeter means where is the particle? Particle will be at y equals to 0, and y equals to 0 means now it is in the xz plane. Where it is? It is in the xz plane. So at t equals to 0.4 second, it will be landed to xz plane. Okay. While moving in its helical path consecutively, where it will be reaching at t equals to 0.2 in this xz plane. All right. So the vertical displacement will be 10 centimeter is wrong. The particle will be in the xz plane at t equals to 0.5. That is also wrong then, because you already checked that at 0.4 it will be in the xz plane, not at 0.35. All right. All right. So that means what is my answer here is A and C. The correct answer for this question will be A and C. All right. Chalo, a good question. Now let's move to the next one. Fine. This belongs to electric potential. Okay. They are asking about the locus of the potential. Okay. Very good. Locus of the potential, quite you can say some mathematics is there, some mathematical calculations there, but since they are dealing with the potential, and potential is a scalar quantity, so I think this question is going to be quite easy for us, not much difficult. So Q1 position is given to you, A and B. There will be some Q1 at the coordinate A comma B. There will be some Q2 that will be at a position MA comma NB. While they are asking about potential at point P, which is x comma y. Okay, so that means the potential contribution at this point P will be because of Q1 and because of Q2. Okay, V1 is the potential at Q because of Q1, V2 is the potential because of Q2. The potentials are same. So correct, V1 is equals to V2. Potentials are same. So let's write down the potential because of Q1 at point P. So we will say it is K into Q by R. Magnitude of R. So magnitude of R from here is under root x minus A whole square plus y minus B whole square. All right. Where is this Q1 is Q? This Q1 is Q, and this Q2 will be okay. 1 minute. Where is this Q2 will be? This Q1 will be Q. This Q2 will be given to you as MQ, means M times more than Q. Okay. So potential because of Q2 will be K into charge is MQ, divided by distance of the point P from the charge Q2, which will be which will be x minus ma whole square plus y minus mb whole square. Okay, let's simplify it. So k and q cancel, square it both the side. So it is m square x minus a whole square plus m square y minus b whole square is equals to x minus ma whole square plus y minus mb whole square. All right, simplifying, this will be the case. Okay, now one by one we have to check all the options. All right, so for the first one, m is equals to minus 1. M is equals to minus 1. Let me write down this expression here. M square x minus a whole square plus m square y minus b whole square is equals to x minus ma whole square plus y minus mb whole square. This is your general expression. One by one we are checking for each options. Option 1, they have given for m is equals to minus 1. For m equals to minus 1. So put it minus 1. So a square is there. So that's why the LHS term will be x minus a whole square plus y minus b whole square. If I put it minus 1 here, it is x plus a whole square and it is y plus b whole square. Either you can expand it or you can arrange the term on one side. So if I am expanding it, x square, y square terms will be cancelled. A square, b square term will also cancel. From here it is 2x and 2by left. From here it is plus 2x and plus 2by will be left. Take it on one side. So finally you are getting ax plus by, that is equals to 0. That will be the locus of that point where v1 is equals to v2. So as you can check, ax plus by equals to 0, that will be our first option, which is absolutely right. So here there is no option, like you have to put the values of m and you have to check. Similarly, for the second one, now they are talking about second one, for m is equals to how much? What is the m value? 2. M value is 2. So just put the 2 value. So it will be 4m minus a whole square plus 4m minus b whole square, that is equals to x minus 4a, not 4a, 2a whole square plus y minus 2b whole square. Okay, expand. 1 minute, this is x minus a, y minus b. Okay, expand it. So this is 4x square plus 4y square plus 4a square plus 4b square minus 8ax minus 8by. LHS side, x square plus y square plus 4a square plus 4b square minus 4ax minus 4by. All right, arrange the terms. 4a square, 4b square, 4a square, 4b square cancel. Arrange the terms. So it is x square plus y square 8, 4, that will be minus 4, 4a by 3. I divided by 3 into x. I divided by 3, it will be 4b by, that is equals to 0. Clearly it is an equation of a circle. X square plus y square minus 2gx plus 2gx plus 2f by plus c. So here, what is the value of g? Minus 2a by 3. What is the value of f? It is minus 2b by 3. That means this is the center of that circle. Locus is the circle whose center is minus 2a by 3 and minus 2b by 3. And if I am talking about its radius, it is under root of g square plus f square plus c. So 2 by 3 is common. G square plus f square will give you a square plus b square. All right. And if you check, obviously it goes with the option 2. 2a by 3 and 2b by 3 are the centers. Radius will be 2 by 3 in the under root of a square plus b square. So option B is also right. Now C. For option C, we have to put now the value as -2. So for C, M value is given to you -2. So there is not much change. +2, this is also 4, this is also 4. Only this terms will be plus. That means only this sign will change. 4x and 4ay sign will becomes plus. So if I arrange the terms, finally what we are going to get here, x square plus y square. Now this -4x, this is coming here, it is 12. 12 by 3. 12 by 3 means it will give you 4a. 12 by 3 will give you 4ax. This is giving you 4ay. Okay, that is equals to 0. Alright, so now if I check here, what is the center? Center here becomes 2a and 2b. 2b. Okay, and what about the radius? The radius will be under root of g square plus f square. So it comes as, radius comes as twice under root of a square plus b square. Okay, under root of a square plus b square. So 2a comma 2b is the center. Clearly this is also right, ABC. Now D. For D, if you see, this is -3. For -3, if you go, for D it is -3. I think for D we don't need to even check also, because for -3, here you are getting 9x square, here you are getting x square. So there will be definitely x square terms will be remaining. Similarly, y square terms will be remaining. While in option D, if you see, this is a linear one only. While in option D, if you see, there will be no x square, y square terms will be left. So obviously, this is going to be wrong, because you cannot eliminate, for -3, you cannot eliminate the x square and y square term. So no need to check for the fourth option, and clearly the answer goes as A, B, C. 3 options, okay? Okay. So relatively, this is mathematics, more of mathematics. Simple question, because you are dealing with the potential, which is a scalar quantity. Okay, now 8th one. Consider an electric dipole comprises two charges plus q and minus q, each of mass m, separated by the fixed distance d and initially at rest, with its dipole moment pointing along I cap. A uniform electric field Ej cap is turned on at t equals to 0 and turned off at t equals to t final. When the dipole moment is making the angle theta f with I cap, so there will be plus q and minus q. That means minus q is here, plus q is here at a distance d. That's why the dipole moment is along I cap, which is q d I cap. But the field will be j cap. The field will be along j cap. Mind it, okay? So that's why this field will be how much? This field will be Ej cap. So if I ask you what is the angle between P and E? P and E, angle between P and E, clearly the initial angle between P and E is 90 degree. That means if I define the initial potential energy, which is minus P dot E, that will be 0. Now you say, sir, potential energy, because obviously if they are asking about the velocities, change in kinetic energy, then obviously we have to use the concept of potential energy. So P dot E initially is 0. Now they are saying theta f is the angle. So they are giving some other situation in which this is the field only, but the dipole moment is making, the angle theta f with the I cap. Okay, so this is plus q, this is minus q, this is theta f. Theta f is not the angle between P and E, because E will be in the J cap direction, while theta f with the I cap. That means if I am looking for the angle, I have to say it is 90 minus theta f. That is the angle between P and E. So now here you see the center of mass of the dipole deflect towards J cap in the presence of the field. Obviously not. Why? Because you know that in the uniform field, the dipole will experience 0 force. That means what will be the acceleration of that? 0 only. So there will be no center of mass deflection. The option A is wrong. Second option, Magnitude of final angular velocity. Obviously, for final angular velocity, we will apply conservation of energy, which is giving you delta U is equals to delta KE. Delta KE, or you can say change in energy will be the final kinetic energy. Okay. Final kinetic energy. So delta K is equals to 0, right? Conservation of energy. So what is the final kinetic energy? Final potential energy will be minus P dot E. And theta angle, as in the second option, it is given to you 30 degree. That means the angle between P and E, we have to take it as 60 degree. So for 60 degree, this value will come as P by 2. Cos 60 is 1 by 2. And therefore, the change is P by 2. So you can say the change is PE by 2, which goes into energy. And what is the energy? It is half I omega square. What is I for this? The mass of each charge is given to you as m, and the distance from the axis about which it is rotating is d by 2, d by 2. So m d by 2 whole square, m d by 2 whole square. All right? M d by 2 whole square, m d by 2 whole square. Moment of inertia becomes m d square. Moment of inertia becomes m into d by 2 whole square into 2, that is m d square by 2 into omega square. All right. Now this is very easy to solve. Just put it the value. So qd into e by 2, that is equals to 1 by 4 md square omega square. 1d cancel, this 2 to cancel, omega will be equals to 2qe by md. 2qe by md, that will be your angular velocity. 2qe by md. So clearly option B is correct. Option B is correct. Next one, if theta f is equals to pi by 3, the change in kinetic energy is 2 root 3. Yes, we can check again. If theta is equals to pi by 3, so if theta is equals to pi by 3, theta f is equals to pi by 3 means 60 degree. That means theta between P and E is 30 degree. That means this time change in potential energy will be 0 minus Pe root 3 by 2. Pe root 3 by 2 minus 0. That will be the change in potential energy, which is the gain in kinetic energy. Which is the gain in kinetic energy. Alright? So here it is Pe root 3 by 2, which is not coming. Here it is written 2 root 3. So numerical values are not matching. That's why C option is wrong. Okay? Then after they are saying for theta equals to pi by 4 the dipole. Okay, they are talking about the time which is after T final. So after T final, what is happening? After T final, the electric field is switched off. That means the dipole, till that time dipole will get some energy, and after that there will be no torque, there will be no potential energy changes there, because in the absence of electric field, so it will maintain that omega. Whatever omega it got by gaining kinetic energy, it will maintain that omega, and thereafter, after T final, obviously its angular velocity becomes constant thereafter. That's why option D is also correct. So for this question, we are going with option B and D. Option B and D. All right. So 4 questions completed. Then the, okay, 9th question. So there are total 5 questions. More than one choice. This is the last question of more than one choice. So they are giving you some thermodynamic processes, and one by one we have to read it and see what is happening. So here 10 moles of an ideal monoatomic gas. So number of moles are 10. Monoatomic means gamma will be 5 by 3, or you can say CV will be equals to 3R by 2. These are the information I just collected. In the state A, atmospheric pressure and temperature is 27. So at A, pressure at A is atmospheric pressure, say P naught, and temperature at A is 27 degrees centigrade, which is 300 Kelvin. Okay, information, got it? The gas is suddenly compressed to the state B. Suddenly compressed means adiabatic. Suddenly compressed means which process is this? Suddenly compressed means this is a adiabatic process. adiabatic process. Okay, and in adiabatic process, if volume is compressed from V0 to V0 by 3, then pressure will increase. So graph will be rectangular hyperbola with increasing pressure. That means if I look into this diagram from A to B, definitely pressure will be increasing. So this first path will be all right because volume will be increasing from V0 to V0 by 3. Compressed to V0 to V0 by 3. Here the temperature at A will be 300 Kelvin. We can find out the temperature at B. If we need it, we can find out the temperature at B. So let's find out. So now for which I can apply PV gamma is constant, or we can say T into V to the power gamma minus 1 is constant. Okay, this is the relation between thermodynamic parameter for adiabatic. So here if I say TB VB to the power gamma minus 1 is equals to TA VA to the power gamma minus 1, and therefore this TB, temperature at B, is equals to TA, that is VA by VB to the power gamma minus 1. So TA will be 300, VA is V0, VB is V0 by 3, to the power gamma minus 1 is 2 by 3. So 3 to the power 2 by 3 you can also write down as 9 to the power 1 by 3. Alright, 3 square is 9 and 1 by 3 remaining. 1 by 3. 1 by 3. So here directly this value is given to you. Directly this 9 to the power 1 by 3 value is given to us in the question, that is 2.08. So I am going to put this value now. 1 minute, something wrong happens. Okay. So 300 multiplied by 9 to the power 1 by 3, which is given to you 2.06, will give you 618 Kelvin. That means I got the temperature at B, which is 618. Alright? 618. 618 Kelvin. No, 2.08. This is 2.08. Okay, wait. I put the wrong value here. As given in the question, this is 6.08. So that means if it is 2.08, that means this will 8 3 24. Okay. So 624 Kelvin. 624 Kelvin will be the temperature which is coming. 624 Kelvin is the temperature which is coming. Fine. Further, now keeping the piston stationary, this cylinder is submerged in water bath of the, so keeping the piston stationary means volume is constant. So isobaric process. So isobaric process is a vertical line, and now the temperature decreases to 11. So 11 is corresponding to, and they are calling this as a state C. That means temperature at C is 11. 11 plus 273, that goes as 284. 284. So at C, the temperature is decreasing to 284 Kelvin. So clearly this path is also right. This path is also right. Finally, while still in the water bath, the piston is brought slowly to the initial position. So now the piston is slowly to the initial position means the volume becomes V0 by 3 to V0 again, slowly. Slowly means keeping the temperature constant. So isothermal process will be again a rectangular hyperbola. That's why clearly we can see that this graph which is given is absolutely right. It satisfies all the three conditions given. And they reach to the final temperature, and final temperature will be also the same because it is a isothermal, 284, 11 degrees centigrade. Okay, so this is the diagram. So correct, the option A is giving you the correct schematic diagrams of PV. Okay, now let's check the other B and C and D. So the change in the internal energy going from A to B, change in the internal energy. So delta U from A to B is given by NCV delta T. That means TB minus TA. Already we have these two temperatures. So this number of moles are 10. This is 3R by 2. Change in the temperature will be 324. Okay, 624 minus 300 is 324. So this is 30 multiplied by 162 into R. So 0, this is 6, this is 8, this is 4, 4860 R. Is it satisfied? 4860 R. Yes. So B option is also correct. All right. Then they are saying net temperature, net change in internal energy for the whole process. Whole process means A to F. Acha, this is the advantage from A to F, that I don't need to check for each process, because you know that internal energy is a state function. So directly you can deal with the initial and final. So like this is going to be NCV TF minus TA. TF minus TA, that is 10 into 3R by 2 into TF minus TA, that is 284 minus TA, that is 300. So 16, 8, 30. 30 into R into 16 by 2, that is minus 8. That means minus 240 R. Yes, this is also satisfied. Minus 240 R means option C. Now last, the pressure at B. Okay, so pressure at B, the temperature is 624. Already we got it. So this is right. What about pressure? Pressure we need to check. So let's calculate the pressure also at B. So pressure at B will be pressure at A into VA by VB to the power gamma. Pressure at A is P naught. Atmospheric pressure, this is V naught by 3 to the power gamma, which is 5 by 3. 5 by 3 I am writing as 3 plus 2. 3 plus 2 means it is 3 into 3 to the power 2 by 3 into P naught. So this is 3 into 3 to the power 2 by 3 is 9 to the power 1 by 3 P naught, which is given to you 2.08. So 3 into 2.08 will be 6.24 P naught. So they are saying 2.08 times of the atmospheric pressure. No, this is 6.24 times of. That's why option D is wrong. So though temperature satisfied, but atmospheric pressure will be not satisfied. It will be 6.24. Okay, so therefore we are going with the option A, B and C for this. A, B and C. Okay, 3 options are correct, A, B, C. Okay. So, numerical values, okay, numerical types questions. There are total 5 questions, and according to the instruction, it will be up to 2 decimal places. 2 decimal places, okay, we have to round off. Marking scheme is +4, no negative marking for this. Okay, so let's go with the first one. So it's from unit and measurement, and okay, optical instruments, measuring instruments. 2 thin wires, wire 1 is having the diameter. So diameter is given for wire 1. For second, it is not given. Fine. And they are using the same screw gauge for both. Okay. The readings are given to you. The readings are given to you, mean scale reading as well as the screw gauge reading. Both are given to you. So first, let's find out the least count. So least count is what? It is the pitch divided by number of turns, okay? Number of divisions, which is 0.5 divided by 100. That gives you 0.005 in mm. That will be your least count. Do you know that how to find out the measured value? Measured value. It is mean scale LS plus it is the CS multiplied by the least count plus if there is any zero error, that is plus that. All right. So for the first wire, for wire 1, if you see, then all the values are in mm. So this is 0.5 plus this is 42 into the least count. Least count is 0.005 mm. Plus we don't know the zero error. This way we are getting the value. Okay. And this value is already given to you as 0.65. That means that will help us to give the zero error. So if I calculate this, this is 0.65, this is 0.5, this value will be 0.5, this is 21, that means it is going to be 0.21, and plus z. That means what is the z value? 0.71 minus 0.65, that will be 0.06. So 0.06 mm will be your zero error, and this zero error will be working for your wire 2 also, obviously, because you are using for the same screw gauge, same circular scale, same screw gauge you are using. So zero error is not going to change. So from the given data you are getting the zero error, and then this zero error I am going to use for the wire 2. So for wire 2, again some readings are given to you. Okay. So linear scale value will be for wire 2, that will be given to you as 1.5 mm, plus circular scale is 95 multiplied by least count, that is 0.005, plus zero error, which I can use the same as we have calculated by the part 1, that is 0.06. Okay, and mind it, this is coming negative. This is coming negative because 0.65 minus 0.7 will give you negative. So negative zero error. So that means here I am putting this value with the negative sign. With the negative sign is minus 0.06. Alright, now calculate this. So 1.5, this is 95,547.457, that is plus minus 0.06. This is coming 1.975 minus 0.06. So this is coming 1.915. 1.915. Okay, 1.915 mm. 1.915 mm. But if you see here, they are asking in micrometer. This is coming in mm. So in micrometer, I can write down this as 1915 micrometer. That means the correct answer for this question is 1915 micrometer. Okay, 1915. 1915 micrometer. Okay, that will be the answer because clearly they are asking in micrometer. Let's move to the next one now. Okay, question number 11. Single diffraction experiment. They are using the diffraction first minima. Okay, in a single slit diffraction experiment, the slit of width 0.015 plus minus so and so is used to wavelength of monochromatic light, diffraction pattern, angular distance between central maxima and first minima. Okay, so condition of first minima for diffraction. Minimum of first order. What we used to do, that is d sine theta is equals to L lambda. So first order means lambda. So d sine theta is equals to lambda, right? This is your d value which is given to you. This is your d. This is plus minus delta d. There will be error in delta d. Similarly, they are talking about theta. So this is your theta. This is your delta theta. Okay, and we have to find out the fractional error in the measurement of lambda. Fine. So it is a question of. So now you know that if I am interested in delta lambda, I have to say delta lambda by lambda, that is equals to first function delta d by d is it? No. 1 minute. I can write down in this way. Delta lambda is equals to what? Delta d. Okay. Delta d into sine theta plus d into cos theta into delta theta. Okay, first function into differentiation of second function into differentiation of first. We have to find out fractional. So that means we are dividing the entire thing by lambda. So if I am dividing this fractional change in the lambda, then this lambda value you can put it as d sine theta. That means the first thing will come as delta d by d. Okay, sine theta by lambda. And here, if I put it d sine theta here, what you are getting? You are getting cot theta into delta theta. Okay, now cot theta. Cot theta value will be cot of 2 degree, which is 1 upon 10 2 degree. And since for a small angle, you can write down this 2 degree in radians. In radians means I have to multiply pi by 180. Similarly, for this theta thing also, it is given in minutes. So I have to convert into radian. So basically it is a ratio. So I think I don't need to convert by this also. Both we can write down in degree, because finally you are getting the ratio thing. So here it is 0.002. That is your delta D by D. D is 0.016 plus cot theta value will be 1 by, in degree it is 2. I can convert into radian also, but I think don't need it. Why? Because it is a ratio thing, so it will cancel out. So 40 minutes can be, in degree will be 40 by 60. This is also degree, so both will be converted into radian, no need to change. Okay, finally we'll solve this. So this is 2 by 8. No, 2 by 8, no, it's 1 by 8. 2 by 16 means 1 by 8. It is 1 by 8 plus this value will be 1 by 3. Means finally you are getting 11 by 24. 11 by 24. How much is 11 by 24? Delta by lambda, that is 0.46. Alright, 0.46 will be your answer. Up to 2 decimal place, answer will be 0.46. Okay, 11 by 24. Fine. Move to the next one. Question number 12. Okay, fine. This question is, you have some mediums which keeps on changing its refractive index, but the good thing is this, all the interfaces are parallel. All the interfaces are parallel means normal is not going to change the direction. So angle will be satisfied. So you can apply this Snell's law in any of the two surfaces. So let us say this is I and let us say this angle is theta. Then the first, if I apply the Snell's law, I can say NW into sin I. Okay, for this angle is equals to again NW into sin theta. That means clearly this I is equals to theta, because will be the same angle, right? If I got to know this theta, then I will get my answer as I in degree. For this theta, they are saying that it is passes in such a way that it will be polarized. You know that in the reflection, when it is partially reflected, then Brewster angle will be the angle at which it is polarized, right? That means if this angle will be, because of the reflection, if it is theta, then this R becomes 90 minus theta. Reason, these two will be at 90 degree for the polarization condition. So it is 90 minus theta. That means sin I by sin R will be tan theta. Sin I by sin R, that will be equals to sin I, that is sin theta, upon sin R, that is sin of 90 minus theta. So it becomes tan theta. Tan theta, which is equals to NP by NW. Alright, so tan theta is equals to NP by NW. What is NP? 4 by root 3. What is NW? That is 4 by 3. That means this value will be root 3. So what is the value of theta here? 60 degree. So value of theta is 60 degree, and as we are already proved by the Snell's law that I equals to theta, that means I is also 60 degree. They are asking the answer in degree, so your answer is 60, 60. 60 will be the answer for this question. So I think simplest question of this test paper. Okay. Move to the next one. Fine. Third, okay, electrical instrument. As shown in the figure, the resistance of the galvanometer G can be found out by the half deflection method. Here the resistance R2 will be adjusted, so it is a variable resistance, fine. And when key is closed, the deflection of the galvanometer is given half of the value as compared to when key is open. So first, let us say this key is open. This RG is given to you directly. That is given to you as 6 ohm. This R2 is also given to you as 4 ohm. Okay. So first, when the key K is open, when this key K is open, that means the circuit is only this one. Okay, this is not taking the participation in the circuit. That means what will be your I in this case? That will be 10 upon R1 plus Rg. That means it is 10 upon R1 plus 6. That is your I. When K is closed, then now R2 is also taking participation in the circuit. That means these two are in parallel. So if these two are in parallel, what is their R equivalent? R dash parallel, it is 6 into 4 divided by 10, which will be 2.4. That means now what is the current capital I? You can say this capital I will be how much? This capital I will be equals to 10 divided by R1 plus 2.4. All right. This I will be divided in two branches as Ig plus this remaining I minus Ig. So I am interested in this Ig, for which you can use the ratio thing. So if I am using the ratio thing, I can say this Ig will be nothing but it is reciprocal. That means it is 4 by 10 of this I. 4 by 10 of this I, which is 4 divided by R1 plus 2.4. As per the question, it is given to you when key K is closed, then the current becomes half. So that means what is given to you, this Ig will be I by 2. Before that, the current which is coming in the galvanometer, now it is coming is half. That means from here we can say I is equals to 2Ig. And if I substitute those values, I can say 10 upon R1 plus 6. That is equals to 2 into 4 upon R1 plus 2.4. So now let's multiply, cross multiply. It is 10 R1 plus 24 is equals to 8 R1 plus 48. So 2 R1 is equals to 24. R1 is equals to 12 ohm. So here the answer is 12. They are asking in this half deflection condition the current in milliampere through the R1. Okay, so you have to find out R1. So R1 I got it as 12. This is not the answer, but why? Because in the answer they are asking current through R1. In which condition half deflection is obtained? In half deflection condition when K is closed. So when K is closed, they are asking this I. Okay, so I just put this I. So for this capital I, we can just substitute the value of R1, that is 10 divided by 12 plus 2.4. So 10 divided by 14.4. That will be your answer, but it is in ampere. So convert into milliampere, that is 10,000 divided by 14.4 milliampere. All right, milliampere. It comes 694. Final answer is 694.44 milliampere. 2 decimal places. Okay, 694.44 is the right answer. Move to the. This is the last question of numerical type. Okay, from unit and dimensions. So you know that any physical quantity Q will be expressed as numerical value and its unit. Numerical value and its unit. That means they are asking for N2, which is N1 into U1 by U2. Of this U1 by U2, for which we need the dimension formula. Dimension formula of which unit? Which quantity? This quantity, mu naught by epsilon naught. This is the quantity. So I'm interested for this dimension formula of this, which you can write down as, see, so many relations are there, whichever you want to use. Suppose if I say 1 upon under root of mu naught epsilon naught, that value will be C. So if I just want to replace this mu naught, root mu naught thing, I can replace it by C 1 upon C into epsilon naught thing. Okay, that way. Can you? Yes. Up here, epsilon naught is what? Epsilon naught is dimensionally. Dimensionally, you can write down this epsilon naught is as q square by fr square. Dimensions of this, which is a square t square upon ml t minus 2 into L2. That means if I substitute here, then this is 1 upon, this is LT minus 1, and this value will be m minus 1, L minus 3, T4, A2. And finally, what you are getting n L2 T minus 3 A minus 2. Okay? Okay. So now to get the value of N2 is equals to N1. We can say it is M1 by M2. Means the unit of mass in the first unit system, in the second unit system to the power 1. Then this value will be unit of length in system 1 and system 2 to the power 2. Then T1 by T2 to the power minus 3 and A1 by A2 to the power minus 2. Now see, in the first system all are 1 unit. Mass is 1, length is 1, it means mass is 1 meter. In the second, mass is 1 kg, in the second unit it is 5 kg. That means this value will be coming as 1 by 5, kg cancel to the power 1. Similarly, length is 1 meter by 5 meter to the power 2. Time is 1 second by 5 second, power minus 3. And ampere is 1 ampere to the 5 ampere to the power minus 2. So this way you are getting N1. How many powers are there? It is plus 3 minus 3. This is 1 by 5 to the power minus 2, which is 25. So 25 times of N1. Now they are talking about what is the value of 1 unit, 1 SI unit. Means N1 is 1. 1 SI unit is equivalent to 25 SI unit in the system 2. Alright. So for N1 is equals to 1, the value of N2 is coming as 25. That means the answer of this question is 25. The answer of this question is 25. Alright. So this is all about the numerical type questions also. Right. Okay. I hope you understand the entire solutions. Some of the questions are a little lengthy, but overall the paper was very good. Okay. All the best.
Okay, hi, this is Sitaram Rao, Senior Faculty in Physics. Now here, I'm going to discuss 4 more problems in Advanced Part 2 Physics paper. So here, the last 4 questions, that means 15, 16, 17 and 18 I am going to explain. So look at the 15th one. This paragraph contains 2 questions that are 15th and 16th. This 15th one is based on +1, that means on fluid mechanics. The same concept, the same idea is given as 16th sum, and the 16th sum you have to solve based on +2, that means capacitor's concept. So now we are going to question number 15. In this question number 15, M1 and M2 are 2 large plates. Okay, the height or the space between these 2 plates is given as 2 meter, and the extreme left, extreme right are empty, that means nothing was filled. But there are 2 chambers prepared with each of length 1 meter and breadth 1 meter. So just imagine these 2 as 2 containers. Okay, each container's cross-sectional area that come from 1 into 1, the cross-sectional area wise they are equal. So don't worry about the cross-section. Cross-section wise both areas are given as 1 meter square. Okay, now at t equal to 0, this first chamber is completely filled with a liquid of dielectric constant 15, whereas the second chamber was kept vacant. Okay, in this problem, what they are asking, after a time t equal to 500 seconds, what is height of the liquid in the chamber 1? Okay, this is chamber 1 and this is chamber 2. Now, this problem we can solve by using Bernoulli's theorem, that is law of conservation of energy in fluids. Okay, now whenever this hole is open, the liquid from chamber 1 flows into chamber 2. So now we are going to apply Bernoulli's theorem. We are applying the Bernoulli's theorem between 2 points, whereas 1 point is at the bottom of chamber 1, 1 point is at the outlet. That means so apply Bernoulli's theorem. Okay, now the bottom of the vessel 1, that is beginning of the hole, for that particular point we are applying. Now the pressure term here is P0 plus consider this particular height of the liquid in chamber 1 is x at that moment. So it becomes rho z x. If it is x, the empty space created become 2 minus x. Okay, now because these two vessels have same cross section, whatever the height that was decreased in vessel 1 will be occupied in the vessel 2. That means here if the emptied space have a length 2 minus x, here the filled one also has 2 minus x and the empty one has x, because the total height of this chamber is 2 meters. So look at them once again, x 2 minus x, x 2 minus x in opposite order. Okay, now here there is no velocity of the liquid at the bottom. So now we go to the second side. Here that particular pressure term P0 plus, since the liquid occupies a distance 2 minus x, this is rho g into 2 minus x plus half rho v square, where v is the velocity of liquid coming out of the hole. Okay, now do the cancellations and try to solve. You will get the velocity of liquid coming out of the hole as root 4z into x minus 1. Now, in order to find what is the height of the liquid at a time t equal to 500 seconds, we need to extend this problem. Okay, so now in order to find the value of x, extend this problem and apply the rate of flow. Here become minus a into dx by dt. Minus indicates the relation between x and t, and here the cross-sectional area of the hole is taken as a and the velocity v. As we know, rate of flow is the product of area of cross-section and velocity. Now this is the time to substitute velocity term here. The velocity is root of 4g into x minus 1. Now, in order to continue, we need to do the separation of the variables. Pull out x minus 1 here, capital A to this side, and dt also to this particular side. And here we have already root 4g because x is the variable. And now think about the limits. For time, you may take the limit as a 0 to t, and for height of the liquid, initial height is 2. After the given particular time, what is the height we don't know, let it be some x naught also. Okay, and this is the time to remove the particular negative sign. We may go to reversal of the limits also, so that the negative will be disappeared from here. Okay, we can continue this, and as we know, integral of 1 by root x dx equal to 2 root x, we apply the same here, so it become 2 root x minus 1 between the limits x0 to 2, and on this side there is small a by capital A root 4g, and on integration here we got so now substitute the limits. In place of x, first there is 2, then x0, small a it was given like root 10 centimeter square convert into meter square, capital A, the cross sectional area of each chamber become 1, and root 4g it become root 40. Okay, if you apply the limits clearly, that become 500. Okay. Finally, after doing all these things, on simplification, we will get x equal to 5 by 4, which is the answer for this particular problem number 15. So here we got x0 as 1.25 meter. So don't go away. We can use the same answer to finish sum number 16 also. Okay. In sum number 16, what they are giving? The difference in capacitance of this arrangement between 0 second and 500 second is given like some 8 minus n into epsilon naught. What is the value of n? So the numerical value of n we need to find. So already we know this particular length is 5 by 4 meter. So the empty space become 3 by 4 meter, and here the reverse will take place. So this become 3 by 4 meter and it become 5 by 4 meter. That means in chamber 1, the filled and empty spaces. In chamber 2, the empty space and filled space. Just look here. This empty space and the filled space, same. This filled one and the empty space are going to be same here. Okay, now just imagine this particular problem. The extreme left and right are not filled. Okay, so initially at a time t equal to 0, this is completely filled with liquid of dielectric constant 15 and it was not filled at, that means empty. Okay, so the extreme parts, the left and right parts which were very large in space have a fixed capacitance, assume that as C0. And now for the chamber 1, just use effective capacity when filled with the dielectric medium completely. K epsilon naught A by D. K value is 15 here, epsilon naught. As the cross-sectional area, it become 1 unit. And D means the entire space between the plates that was fully occupied by the material, that is 2. And next, this is empty, so 1 into epsilon naught by 2. Finally, the initial capacitance we will get as C0 plus 8 epsilon naught. Okay, this is the capacitance at a time t equal to 0. Now, at a time t equal to 500 second, if you observe in this particular problem, The extreme left and extreme right are same as unfilled, but this was empty space, this was filled space. And here the reverse occurs. Okay, just look here. These two chambers capacities we can find separately, individually. So this empty space C1, this filled one C2. Here the empty one C3, filled one C4. And if you just imagine, it may be taken as positive plate, it may be taken as negative plate. Now, this is C1, C2 are in series. This is C3, C4 are in series. But entirely all of them are again in parallel. That's why the capacitance at t equal to 500 seconds we can find using C0. What is the capacitance of the empty space or on the extreme left and right sides? Plus, this particular portion has two capacitors C1, C2 which are in parallel. So C1, C2 by C1 plus C2. Next, C3, C4 by C3 plus C4. Here the important point is we need to create C1, C2, C3, C4 clearly. C1, because it was empty space, 1 into epsilon naught by d value 3 by 4. So we will get C1 as 4 epsilon naught by 3. C2, it was filled with dielectric and the d is 5 by 4. So finally 60 by 3, 20 epsilon naught. Next, C3, it was empty and having 5 by 4. So finally it will become C4. It was filled with dielectric. So now it will become 20 epsilon naught. After substituting all these things, we will get the capacitance as C0 plus 128 by 65 epsilon naught. And the given value contains delta C. Delta C means C final minus C initial. Okay. That delta C you may take as n epsilon naught, where n equal to 128 by 65. So by 65. That we can write like 1.97. So the final answer for this particular problem is 1.97. So the sum number 15 and 16 are from the same arrangement, but one is in +1, another one is +2. So in +1, we have used the conservation of energy in fluids and then equation of continuity. And in +2 topic, what were used? The basic idea of series and parallel combinations. Okay, now we are going to the next one. Look here, this is sum number 17 and 18 based on this arrangement. So it is a circular disc of radius 0.2 and mass 1 kg. It was pivoted at point C. Now a particle initially moving in this particular direction strikes with a velocity what? 100 meter per second. After striking, the velocity become 90. Okay, acceleration due to gravity is also given like this. Okay, here, what basic idea we need to apply? First of all, because after collision, whatever may happen during the collision, so here we need to check whether we are going to apply conservation of linear momentum or conservation of angular velocity. Because it is pivoted at point C, whatever is going to hit after that collision, this disk has to rotate about point C. That's why the idea here we are going to use is law of conservation of angular momentum. So initial angular momentum equal to final angular momentum. Initially, particle is having a linear motion about point C. So about point C, if you want to find angular momentum, we must find the perpendicular distance of this linear momentum about C. So this OC is already R. Okay, OP is also R. If you go to the resolution, it becomes R cos 45. So it is R by root 2. This is also R sin 45. It is also R by root 2. That's why initially when the particle is running with a velocity of 100 meters per second, its perpendicular distance from point C is R plus R by root 2. So in the entire system, initially only one member is moving. Later on, after this hitting, this particle velocity is changed both in magnitude direction. The velocity direction is along negative y-axis. So the perpendicular distance is along x. It will be R by root 2. Okay. As a result, this particular disk also needs to rotate about point C. So for that conservation, the angular momentum of the rotating body, we can take like I omega. So the final calculation we will see in the next page. Look here. So now if you finish, on the left hand side we have m into R plus R by root 2 into 100. On the right hand side, okay, in place of I, because this particular disk is to rotate about point C. So this particular point C is going to be the axis which is tangential and perpendicular to plane of the disk. Okay, that's why the moment of inertia of that particular disk become 3 by 2 mr square. Okay, as all the values were given, radius, mass, small m of the particle, capital M of the disk, radius of the disk, everything is given. If you do the calculation after simplification, we will get this value omega is around 7.138 radian per second. But there the problem is not going to end. Actually what they want in this particular problem, they want the maximum change in height of the center O. Okay, now this particular center, because of this hitting, this particular disk is to rotate in clockwise direction. At one particular moment, this particular point O may rise to a height h. Okay, so to find that particular height, just use the law of conservation of energy for the disk. Okay, so before this application, just look at the initial, that means after the impact the disk have rotational kinetic energy, so go for half I omega square as the initial Ke. Now it is gradually moving up. Oh, as it goes, its velocity becomes 0. At one particular moment, it may be momentarily come to rest. There the entire energy converts into potential energy. So here, in place of I, you may take 3 by 2 mr square. All the values here we know. So finally, it will become 3 by 4 r square omega square z. After substituting this omega, which was already earlier derived, you will get this final answer as 0.15 meter. So in this problem, firstly, the conservation of angular momentum is applied. Thereafter, getting omega value, conservation of energy. So this is law of conservation of energy for the disk. Okay, so hope you understand. This is the value. And this is the time to go to the next problem, that is question number 18. In this particular problem, in the same situation, what they are asking? A loss of energy during the collision. Yes. In order to find the loss of energy during the collision, just imagine the loss of energy is just the difference of energy, which is in the form of kinetic energy, initial and final. Initially, because the particle only moving, so the kinetic energy is half m v1 square. After impact, the particle is in motion but with a different velocity. As you know, in the problem it was given like 190. And now, after this impact, this disk is also in motion. That's why this is the total energy appeared in the problem before the collision. This is the energy appeared after the collision. If you take the difference, that is going to be the answer. Okay, now you take half common. Okay, already we know the values. Mass of the particle, velocity is v1, v2, and already omega was already derived in the earlier problem. In place of I, you can take 3/2 m r square. Here m is m of the disk, and this m is m of the particle. Okay, after substituting all these things, because all the values we are well aware, so this particular value we will get like 17.47 joule. So in the problem number 17 and 18, what was done? For the problem number 17, we have just applied conservation of angular momentum, then conservation of energy. And here there is no hidden topics, just clearly final energy and initial energy were subtracted to get the loss of energy in this particular condition. Okay, bye.